Good morning. Can we daily continue the pinch the case study? The pinch is for immigrant system. You may refer to the slide like that in Egypt. So it's number of the slide that it's available. So this is based on the case study in that is by almost Skudai. And the paper is this is six. What are the pinch? So for this topic, we will refer to this slide, and some of the information is not available in the slide, but is available in the paper itself. The, the urban sector contributes a significant percentage of water consumption, particularly in developed countries of warmer climates. In Malaysia, for example, the domestic sector contributes 60% of the total consumption compared to other sectors. This is statistic in 2006. The majority of work on urban water conservation is focused on design of water saving gadget and wastewater recycling. Before we continue, take the attendance first. Okay. So for this topic, yes, can you attendance first? So for this topic, we learn Oh, no. Thank you. Let me. So in water distribution, it is possible to determine the maximum water cycle for it. The cascade. Know that the maximum water cycle flow rate corresponds to minimum freshwater consumption. So you have learned before this, we want to minimize the amount of freshwater consumption by either we reuse it or we recycle or we regenerate it, then reuse or recycle. Reuse and, reuse and recycle, two different things. Can refer to the previous slide. I post two exercise. So this, for my part, since I am required by final exam to contribute to the final exam question. So my question for the final exam is based on the exercise given. At the moment, I posted two exercise. Have to do both and submit through ellipse. Started March. We will go through the second exercise today. Required to do it during the class. We will check it if the time permit. We will also continue for the cascade analysis, but it's okay. We have another meeting tomorrow. The first key step toward minimizing water, freshwater consumption and wastewater generation is to establish the baseline minimum water consumption target prior to the design or profit of urban water network through the notion water targeting. So in this case study, there are two methods will be compared. The first method is just to retrofit, meaning using their common sense, they just retrofit and see what is the outcome or output. The second method is we do the water cascade analysis first. So before we can do water cascade, we need to get all the information, the flow rate, the concentration of the pollutant. In this case, it's not easy to detect each of the pollutant. So we need to, then they will use a method that can provide an overall quality of water, like we have noticed BOD, COD, the one is showing overall water quality. Since both is part of the water standard, underwater standard quality guideline, is value easier to use both or any description of how the water cascade analysis technique WCA was adapted to establish the minimum water targets. For the Sultan Ismail Mosque at the University of Malaysia, Technology Malaysia, UTM, this is Skudai, the main campus, Skudai Johor. So figure 4, if you refer to this paper, some of the info is available in the paper, but most of it is coming from the journal. You can refer to, I'm not sure which number of the paper, but it's there in ellipse. So figure 4 is the actual water distribution network. without any changes. So all of the water is sourced from fresh water, about 29 ton equivalent per day. However, this value will increase to 60 meter cube per day, 5 days, 5 day per year. The fresh water is stored in 4 interconnected distribution tank. This is the distribution tank. So each tank can store around 237 meter cube. The estimated total fresh water consumption for most is 11,550 meter cube per year. During the semester, the amount of water consumed for vision is around 60%, but only 25 on other days. So in order to estimate a reasonable typical water saving for the most, daily water consumption calculation will based on normal semester days. So we go through the process first, the distribution network. So fresh water from the municipal, 29 equivalent per day, divided into two. Most of it goes to the storage tank, interconnected tank. This is the distribution tank. Then some of it goes to the kitchen. So from the kitchen, produce 0.03. So this is water sink. This is water source. Sink, source. Sink, source. Source. But this one is distribution again. This one is sink. So 25 goes to the kitchen. You see the concentration. 23. Some goes to wash machine, shower, mostly irrigation, toilet pipe. So for the toilet pipe and flushing toilet, rainwater, meaning you see there's no, they didn't provide the concentration. And the water quality, because this is will not be reused for the toilet pipe, flushing toilet. This one goes straight to the wastewater. For the irrigation is goes straight to the soil. So, however, for the water that has quality, the more ppm is will be part of the calculation. So the ablution water, rainwater were to be filtered solid particles like a stone before going through a series of treatment using activated carbon and microfiltration processes. Okay, refer to the paper, page page 55. So for the first proposal coming from Institute of Environmental and Water Resource Management, UTM, they proposed a water recycling scheme aimed at minimizing fresh water consumption for SIM. The retrofitted network design proposed by IEWRM is shown in figure 5. This is figure 5. Hmm. This is figure 5. This is the treatment. So the proposed idea is to reuse or treated ablution water and rainwater. Yes. If you refer to this, another source of water, this is not part of the network distributed from the distribution tank. This is the rainwater harvesting. So for the proposed system, it will be using activated carbon and microfiltration process. The treatment process was to ensure that water being recycled to the distribution tank was of acceptable purity for users which involve bodily contact. So the water from the treatment, refer to page 56. Oh. So water from the treatment, this is verse IAWERM, goes back to the distribution tank, mix again with the fresh water. So instead of using 29 ton equivalent per day, since we can reuse, then treated it plus rainwater, we can they can save around how much? 8, uh, 8, yeah, around 8 ton equivalent per day by installing the treatment. The amount of ablution water requirement. So for this method, the IEWM, they didn't do any water cascade analysis. Meaning they just think, okay, how about we treated the ablution? Since ablution has the highest a day around 35 ton equivalent a day. So the amount of ablution water reclaimed, rainwater collected was limited by the existing distribution tank. Treated ablution water could only be sent to the last distribution tank. Since the water output was approximately 29 for the fourth tank, only 7. Treated water can be fed into the last distribution tank. The flow rate of 7.27 ton per day is the limiting point of bottleneck of this system. So during the rainy season, rainwater was collected instead and spent ablution water diverted to the sewer. So this is the drawback. So during the rainy season, rainwater was collected and the spent ablution, meaning water from the ablution here, yes, goes straight to the sewer. Since the system is only capable of recycling 7.27 ton per day. So this design allow an estimated freshwater saving up to 25% with payback period of for investment of 10 years. Lama. Okay. That is the first proposal. Okay. The most study is strictly speaking a batch process. Since all the water using utility occurs in discrete time period, yeah, it's based on the during the praying time. That's when the water using utility will occur. This is why it's like a batch process. However, in this case, it is possible to use WCA technique develop for a continuous process to establish minimum freshwater consumption with water generation target. The availability of storage, fixed pattern of water utilization allow the most case study to be modeled as a repeated batch process that approaches a continuous system. First, a total building review is carried out to have a good understanding of the initial water public and sanitation of the building. So for this study, they are using BOD to combine. Yeah. So for this study, they are using BOD to the way to determine the water quality. Next is the data acquisition and extraction affected by surveying the water flow rate, contaminant concentration at the source, at the discharge. So before we can setting the minimum water target using the water cascade analysis, we need to acquire all the information, all the data. Yeah. So to get this data here is not available. So we need to come up with the process with the water distribution network. So with this data, the process program or the initial water network can be obtained like that previously. Subsequent WCA is constructed to achieve the true minimum target for the water network. Finally, a water network is designed before the economic analysis is carried out to show the total savings of the new water network. Mm. So we go to the paper now, page 57. So for this case study, they are using BOD. Fecal caliform was not selected as the quality factor since regeneration was proposed to enable the grey water to be reused safely. This regeneration consists of three main test steps. First one is the filtered for the particle, next is the filtered carbon, then the chlorine or UV used to disinfect the grey water for storage purposes. So table one and table two summarize the water demand and source for SIM. SIM is short form for Sultan Ismail Mosque. There are 8 water demand, 6 water source, 8 water demand. 8 yes. So the water demand is water goes to the ablution, goes to the wash basin, to the kitchen, what else? Oh, yeah. All the goes into the white box, except for the water, of course. Then the water source is water coming out from the white box. The box of kitchen, ablution, waste basin. So in this case, rainwater is the water source. So water sources are just available for possible recycling, while water demand reflects the actual requirement of various water using processes, black water. So black water from toilet pipe and flushing toilet will not use. It is highly contaminated with urine disease. And water formation is due to the ingredients of violence. It is the standard that they use for the water quality. It's not just Malaysia, it's many, many standard. Table 3 shows here. Uh, the US EPA set conservative water quality standard for BOD level to be reduced at least 10 ppm for non-potable domestic recycling. Non-potable water refer to the water that is not used for human consumption. But you can use it for the bodily contact, just not for the consumption. So it's not drinkable. Since all the water uses after the distribution tank in the most is non-potable water, a maximum within limit of 10 pm was set for the demand. A building value of 0 pm was set for kitchen water demands. For the kitchen, it is using a fresh water. Mhm. So now is the water targeting using WCE. Okay. Slide. So the first, if you remember what the cascade damage is, sorry, Japan. If we refer to table 6, the interval water balance table for the Sultan Ismail Mosque. So for this table, how many column? 7 plus 1. This is the interval column 1, 2, 3. Some of the papers they use K, it's the same. Some using label, same. So 1, 2, 3, 4, 5, 6. Although there are 8 in total, but the interval is 6. Okay, start from the concentration first. So for the water cascade analysis, it must you need to sort it in ascending order. So from 0 to a million, this is the maximum for ppm. So 0 is reserved for the fresh water. You see here, look at table 1 here. So the 0 ppm POD concentration is for the kitchen, 31. So how to calculate purity based on equation 1? 1 minus 0 over 1 is 1. The next one is 10. So we have several any 10. If you refer to the figure 4, the demand, the water demand is not standardized. Some is 0, some is 1.21. This figure 4. So based on their view of the existing standard, they found that the BOD level, the minimum BOD, not necessarily must be 0, but the minimum BOD level for non-potable domestic water recycling around 10. This is based on US CPA. So, and Japan standard also 10. So that's why they choose 10 for the water demand. Meaning in the figure here, over here, so the input inlet for the quality is all 10 ppm, 20 ppm. On it's not necessarily must be 0. If it's 0, then you just use fresh water like yeah. This is using fresh water. Okay. Then we calculate the delta P. So this is interval. So interval is between the concentration, between the purity. If you use a level, then it must be in line or aligned with the 0, aligned with 10. Interval is between 0 and 10. That's why you see the cascading. Next, calculate the delta P. So 1 million minus 0.99990 equal to 0.0000010. Like binary. This one 0.99990 minus 0.999977 and so on until wait here. Boleh, huh? Why is 0? Because 1 million minus 1 million is 0 divided by 1 million is equal to 0. That's why it is 0. Then we do the summation for the water demand at 0 ppm. Only one value to the kitchen. So negative 0.03 Also refer to the paper. This is table 6, page 60. So if you refer to the paper, some function needs to be done. For the 10 ppm, there's a lot of 10 ppm. 25. So you add up this one first. Then put negative plus. That's 25 plus. That. That's all for the water demand. How do you know? Because it's only then 2 concentration 0 at 10 pm. Now goes to the water source. Of water source. So for the water source, it started at 10 ppm. So no value for the 0 ppm. So at 10 ppm, since this is the water source, is in positive. Start with 11 and 14. Then next is the 23. So for 23, there are two values. Have 25.03 plus 0.14 for 216 for 72 by 36 ppm. So this is for the water source. Next is the summation of water demand plus source. This is just the water. Negative 0.03 plus 0. 82.99.7 plus 11.14 is negative 17.93 and so on. This is forward same. Then we identify the meaning. Then we identify the demand in the source. Oh, demand is negative. The source is done with the interval water balance.
Hi, Doctor.
Next is, yeah.
Can you repeat how to get the column number 4 and number 5?
Number 4. So for the column number 4, this is based on water demand. So for the water demand is limited to 0 and 10 ppm. We start with 0 ppm first. So for 0 ppm, is the demand is only for the kitchen. 0.03 ton per day. So since this is a demand, so negative sign. If you refer to the paper, it's actually for the 10 ppm, it's 9.07. You correct it. It should be negative 29.07. So for the 10 ppm, we sum all of this until 10 ppm, negative sign. You add it up, it will be 229.07. For the
Why
source,
we
yes.
why we add up and then put negative again?
Because it's water being used. Water being used by the activity.
Oh, okay, understand. Because it's the same concentration 10, so we sum up all the 10 one lah.
Yes, correct.
Okay, understand.
For the source, it's safe. But normally for the water demand, it's like this. It doesn't like change much because this is what we said. But for the water source, yes, this is based on the activity. That's why the concentration really vary. Like you see the kitchen, we started with 0 ppm for BOD. and up with 156. Okay, next. Done. Yes. This is the water cascade diagram. So before we can do the water cascade analysis, we start with the interval water balance first. For the interval water balance, compile all the data from the process diagram, process flow diagram. Once done, then we can draw the water cascade. Not necessarily draw. You can actually use water cascade analysis by extending this table 6 as well. But the table will be very long. But at the end, it's the same thing. So therefore, the water cascade analysis. So for any water cascade analysis, we will start with the fresh water feed 0. We assume the system will not require the clean water in order to find the minimum minimum water target. So this minimum water target will be the next later on be the minimum fresh water needed for this system. So the first column, this is from table 6. From table 6 as well, this is from table within P1. Okay, from here, the cascade started. The fresh water feed to 0, then goes to the summation of demand plus the source. This one, column number 6. That is what? So this is aligned with the level. This is the table. Next is we do the cascading. Cumulative water source / demand. So 0 plus negative 0.03 plus this one, and get negative 17.96 plus 25.17, we get 71, and so on, plus till level 6 concentration, the highest concentration. From cumulative water source or demand, the method is the same based on previous slide. Mm, The method is the same as previous slide. This is the pure water surplus or deficit. For pure water surplus deficit, it's actually multiplying product of the cumulative net resource or demand one and a pretty different delta P. So meaning cumulative water demand multiply with the delta P. So for the first pure water surplus, the value is not zero, but it's a lot of zero. How many zero? 6 of zero. 0.000003 or negative 3 times 10 power of negative 7. Not sure why they put 0, maybe because of the value is very, very small. The system or the what, they just assume it's 0. Otherwise, it's not. And do the same for the other interval. So this one is still 17.96. 0, 3, 0. It is 0.00023308. It's similar. That until the value will be 6.7. Next is the cumulative pure water supply. So for the cumulative pure water, we do the cascading again. This one is the same plus this value. You get this value plus this value, get this value until 7.669417 ton. So if you notice, this is the fresh water, this is the wastewater. So without fresh water input, we will generate like 7 ton equivalent per hour of. The next is we do the interval fresh water demand.
Hello, doctor. Can repeat on how to get the negative 0.0003 and then negative 0.0233.
This one? This one?
Yeah.
Yeah, okay. So for the pure water surplus deficit, this one is multiplication of delta P and the cumulative water source slash demand FC. If you multiply these two values, you will get 3 times 10 power of 7. So if you have a paper with you, you can do the correction. And do the same for the other interval.
Oh, okay, I get it.
For the interval fresh water demand, check. Please. Itu dia dalam tu. Oh, column C. Okay. So for column C, the calculation is like this. Negative 3 times 10 to the power of negative 7 by 1 minus 0.999 Oh, lucu. 5. Okay. Ini right dulu. For interval freshwater demand at level K, it is available in the books, sorry, in the paper. The one is equation 4, page 62. But for the calculation wise, it is 10 to the 7 by. If you refer to question 4, it's PFW. PFW or freshwater, purity of freshwater is 1. Yeah, freshwater is 1. So the contaminated water, it's 0.999, 0.9997. How do you know? You calculate using equation 1, the paper. The purity 1 million minus C over 1 million. 0. Right. So this value is similar to this. How about this one? Same. If so since the equation is specifically indicate it must be a PFW, although this is the level, third level already. So it should be 1 as well. It's not like you minus it with previous level. This one it should be 1, still 1. But the PK or level is based on level 3, yeah? 9, 9, 9, 7. Equal to 10, 6. Let's check it. It should be sama, negative 10.17 mil. If you don't bunda kepada nearest integer, apa itu? Macam 7B. Hmm, 7B untuk. Okay, 7B is page 62 in the paper. Okay. Notice that for the pure water cascade figure 7B, 7, is 7B. Cumulative pure water visits are observed from second to third purity level P2 and P3 to 3. The deficit on the pure water cascade, which corresponds to the negative region of early water surplus diagram, figure 9a. This is figure 9a. Indicate that the pure water cascade is infeasible. This deficit means that there is insufficient fresh water in the network and are the result of sending a zero fresh water flow rate during water cascading. Thus, additional fresh water should be supplied to remove all pure water deficit and yield a feasible pure water cascade. So in this case, if we were to use zero fresh water, then this is the system is not feasible because not enough water. So how to make it enough water for it to become feasible? We need to add additional fresh water, but by how much? This is where the pinch this is important. Okay. Fresh or pure water is to be supplied at the highest purity level. So the highest purity level in our case, this case is 0 ppm. To minimize fresh water, it is necessary to determine the minimum flow rate of fresh water or the interval fresh water demand that will satisfy the total water requirement at each purity level. The interval fresh water demand restore a feasible pure water cascade to the water network. In figure 7C, 7C. Oh, udah, udah kira dah. Okay. We already calculated this one using this equation. Even though at purity level 4, we still use 1 because it's a PFW to purity fresh water. But if the purity of fresh water in your in the exercise, another question example, started at 10, meaning the purity P1, sorry, PFW is 1. This is based on the highest purity available for the process. If the highest purity is 10, then the P2 is 0.9999. Okay. Yes, we will see it. Referring to figure 7C, 7C is here. Interval freshwater demand. A negative value for FFW means that there is insufficient fresh water, whereas the positive FFW means there is excess fresh water at the purity level K. So here is insufficient fresh water. This is excess fresh water. In order to ensure that there is sufficient fresh water for at all point in the network, so at the end, this column C, the fresh water demand must be all positive. So it must be excess to ensure it is sufficient. A fresh water flow rate of exactly the same magnitude as the absolute value of the largest negative, 10 point, negative 10.16, should be supplied at the highest purity level of a feasible water cascade. So the F FW4 W4 kah? 3 3 W3 yeah, level 3 of 10.16 lah. Is found at the third QT level ya. Tu pula of the cumulative fresh water cascade in figure 7C as the largest negative FFW. This quantity of fresh water is added at the highest QT level of the visible water cascade in figure 10. The 10. Belum juga figure 10. The 10. Oh, the 10 yes. So the highest negative value was is the minimum water required to make this to make a visible water cascade. So this value negative 1016 goes to the freshwater feed. Then we do the cascading again, calculation again. But now, before this, we assume it's a 0. Why we assume it's 0? To identify how much is the minimum water target. Since we identify the minimum now, then we use the minimum as the reference for the freshwater required system. This is the same as table 6, same as table 6. This is the same as table 6. The difference is it now the minimum is 10.16. So if you still remember, without the water cascade analysis, they need around 29 ton equivalent per day. And the method one proposed by IEWRM can only reduce up to how much? 25%. Yeah, from 29 to 21 fresh water needed per day. But using cascade analysis can reduce up to 10 ton equivalent per day. Next is you do the water cascading 10.16 plus 0.03, you get 10.13 plus 17 and 93, get negative 7.8, and so on. So now the water, sorry, the wastewater, is it increasing or decreasing? Increasing, yeah? Since this one is increased, of course the wastewater is increasing as well, up to 17.83 ton per equivalent hour. Let me check this. How much is that? So that is that. Oh, yeah. If you refer to the figure 4, the water distribution network before any changes, the original water distribution network. This is based on mass balance. So what goes in is equal to what goes out. So since they are using 29 ton equivalent per day, so you can safely assume that based on mass balance, then they will the same value 29.1 ton equivalent per day will go to the wastewater. So by using this method, water cascade means we can reduce the wastewater from 29 to 17 and freshwater use from 29 to 10. For the pure water surplus, this is multiplication of delta P in the fifth loss. Then we do the cumulative cascading again. You see here it's turned to 0. Yeah, pinch. The pinch point. Not that. That's what I thought. Later we go for the regeneration. The other regeneration inside the paper. Inside the slide, got the note. Not that visible water cascade is the one that is not for at least pure water surplus. It's a pure cascade. The visible water cascade yield the true minimum freshwater wastewater flow rate target of 60, 17, 83, 23, 28, 40 for most cases. But that's through the WCA we have obtained the utility target and ahead of design. Initial design achieved the maximum water recovery objective for the plant, the water cascade, the water surplus. Pure water surplus cascade again can be included in the table water value table to form the water cascade table WCT. So how to reduce it more? We need to regenerate. Through the WCT, or this is page 63, through the through the WCT, the WCA technique offers two key advantages over the water surplus diagram in raising the minimum water target. Apart from its power to eliminate the tedious iterative step of water surplus diagram to yield the exact target and pinch location quickly. The first key advantage is that WCT clearly display both minimum freshwater and maximum flow rate with the cumulative net water source or demand. 377. This is the water cascade table. Now that in the case of water surplus diagram, only the minimum freshwater target is known. However, the target of the minimum wastewater flow rate target is not available from the diagram. The second key advantage of using WCT is that it enables designers to identify the pinch causing stream and the exact water allocation for the region above and below the pinch to achieve the minimum water target to the unit design. Earlier reported that pinch always occur at the pretty of a source, according to the source pitches below the demand, to bring above the demand, table 7. Zero cumulative pure water surplus at temperature level 3 or 0.999977 represent the pinch point. This level between 2 and 3. Yes. Note that the pinch crossing stream which exists at this purity level is the water source summation Fs of 25.17 here, referring to table through this stream generated from the two water source, the ablution and the wash basin. So if you refer to the diagram, process per chart lah. So 25.17 is from 23 ppm. So 23 ppm, there are two sources. If you refer table 2, summary of water source from Sultan Ismail Mosque, there are two is ablution and basin. So these two is the pinch point for this process. So in order to realize the pinch point and to achieve the MWR adjective portion of the pinch crossing stream, in this case, ablution and wash basin has to be allocated to a process above the pinch, while the rest of the process below the pinch during work design. The exact water allocation is available from the WCT referring to the normative net water source of table 7 out of 25. 0.17 water source population within 7.8 of water found between P2 and P3 is 7.8. Must be sent to the region above the pinch. So if it above the pinch, then you can see how many. Oh, the 10 and the 0 lah. The 10 and the 0. The 10 and the 0 is one is referred to table 1. Oh, even can go to the rainwater. No lah. So most of the 10 is in the most of the 10 ppm is in the water demand. Must be sent to the region above the pinch. Negative sign indicate sending water across the reverse. On the other hand, 17.37, this is below the pinch, found between P3 and P4. Level P3, P4. If you refer to table 7, this one is interval. It's different. Must be sent to the region below the pinch. Okay. So region below the pinch is many. Have pada how many dah? How much? Below 23, yeah. You have 216, 472, 536. The exact water allocation period can be readily verified with any detailed network design technique. Okay. Right. Okay. Before we go to the registration, let's stop for 15 minutes or 10, 15 minutes. Those who haven't registered your in this row, Continue. Okay. Go to the paper, page 65. After regeneration using the reducing paper. So two possible scope for process changes to reduce the target further. So meaning reducing from 10 to 16 fresh water then 16 ton equivalent per day for fresh water feed. So to do that, based on this paper, two ways to regenerate water to modify the heartway. So water regeneration above the partial or total upgrading of water purity using purification techniques such as wastewater treatment like microfiltration, greenhouse filters, and filter. The regenerated water can either be reused in other water using processes or recycled to the same process to reduce further water consumption in this water generation. They are guide for regeneration of water source. Regeneration above the pinch. Now that we know the pinch is located at between interval 2 and 3. Regeneration above the pinch. Water source in the region above the pinch are partially treated to upgrade it to 2. So to upgrade the purity doesn't necessarily it must be 0 ppm. It could be up to 10 ppm or less than that. Regeneration across the pinch. Water sources in the region below the pinch are partially treated to achieve purity higher than the pinch value. So pinch is at concentration ppm 23, yeah. See here. So below the pinch is 216, 472, 536. So in the case of number 2, guideline number 2, relation across the pinch. So water source in the region below the pinch or yes. So for the number 2, point number 2, across the pinch means at 23. So at 23, we can purify it so that it's higher than, lower than the pinch. So meaning better quality, B to 10. The third one is region below the pinch is water source in the region below the pinch are partially treated to upgrade the quality. However, the resulting water source is still maintained below the pinch. So for the last point below the pinch, so here, yes, can treated it, but not up to the So more than the pinch. Note that the regeneration above and across the pinch reduce the freshwater consumption and wastewater regeneration, while regeneration below the pinch only reduce wastewater use. So any regeneration done at the pinch or below the pinch, not below, above the pinch, if we choose this region, then we can reduce the freshwater consumption and reduce the wastewater generation. However, if we choose to treat the water below the pinch, it is only the freshwater will still the same 10.16, but we can reduce the amount of wastewater. Table 7, this is the Table 7 show the pinch concentration for the most process at 23 ppm. One possible option of regenerating the water source is to treat the pollution water to a concentration above the pinch. Pollution water is 23, 23 ppm. Pinch is at 23. So unlike all proposed treating domestic wastewater using microfiltration, to reduce their contaminant concentration of POD from 59 ppm to 4.2 ppm, also under contaminant concentration. This one is table 8. Table 8, okay, page 66. The amount of pollution to be treated depends on the cost of the treatment equipment, analysis of the relationship between treatment equipment costs, and flow rate must be established to know the amount of water needed to be treated with the test and appropriate payback period. The total amount of ablution water to be treated using microfiltration is set to 7.27 ton equivalent per day based on IEWRM. Refer to table 9. So IEWRM, if you still remember, they propose to treat the pollution and the rainwater. Table 9 from the diversity shows the new pinch quality at 0.997 ppm and the freshwater reduced to 4.22 and 11.89 respectively. The network designed by and will be control this target. So for this case, they treated the which one they treated? Wait, they treated the using the microfiltration. They treat the ablution water to 4.2. Solution water is 7.27. 7.27. Oh, yeah. They want 7.27 water source. It's not clear which one that they regenerate. But from the paper, it seems like they treated regenerate the ablution water of the ping ablution water is or is a lot. 25. Mm. And right, that's that. So, yeah, busy media. Yes. Yeah. If you refer to table 9, this is partial regeneration of ablution water. So in this case, I'm not sure why they choose 7.27. Maybe based on the method 1. If you use method 1, then you can only get 7.27. They use that value. Treated the ablution water, which is why if you see ablution water in table 2 is actually 25.17. Yes. This value, uh, so this value is uh, 25 and 17. So minus 7.27, you get 17.9. This value. So they treated it until the concentration goes to 4.2 below, sorry, above the oh yeah, demand, water demand, minimum water demand, minimum water demand. Minimum water demand for this case, the water cascade, it's 10 ppm. Well, since this is lower than that, so in ascending order, we need to do it again like this minus. So for 23 ppm, some of it have been treated. So that's why the value here is lower, smaller. So again, table, refer to table 1. So for table 1, because for 0 ppm is only table 1 kitchen, not table 1, only for kitchen. At 0.03, the negative 0.03, this is the new liquidity level. So 4.2, how you get this number? 1 million minus C over 1 million. This is 7.27 water source because we treated the source. And okay, 7.27. Next is at 10 ppm, 10 ppm remain the same. So for 10 ppm is mostly from the ablution. Some of it is coming from the water source, rainwater. And then what else? 23 the same, not the same, different. Because partial part, some of it have been regenerated close to 4.2 ppm. 216 2 536 is the same. Then we do the FC gain. So you calculate the FC. It's a multiplication of delta C. Or say that delta P. So multiplication of delta P with the summation of demand and source. They say, you know, oh sorry, oh sorry, multi-quarter source. You want this plus. Hanya terbalik. Oh, ini. Ini tidak ya. Kita tahu dulu. Terbalik. Ah, ah yes, yes. FC datang. FC is cumulative factor source demand. Okay, so for cumulative factor source demand, this one is based on the cascading. So after we introduce the new process purity level 1, purity level 2 here, we need to start FW, start from 0. Once you start from 0, assume there are no fresh water feed needed, then we can identify the minimum water target. So the minimum water target is here is actually negative 1.22, become the pinch, meaning negative 4.22 is the largest negative for the cumulative pure water surplus. Once you identify the pinch, meaning this value, then this value goes for the minimum freshwater feed required. Then we can, meaning if you answer the question later, you start with FW0, get the minimum water target. Once you identify it, it goes to the FFW, make a new table, recalculate everything, then that minimum target will turn to 0, which is the pinch for that process. So after the regeneration, you can see here, it's true, the guideline. If you regenerate above the pinch, it will reduce the amount of wastewater needed, fresh water needed, and the wastewater generated. See, this without the regeneration, then reduce to 4 only, is reduced to 11.89. It's good. So designing a water network that reuse wastewater is needed to shortage of freshwater and reducing cost of wastewater treatment. Reusing, regenerating and reuse wastewater, reduce freshwater consumption and wastewater emission. Wastewater can be reused directly in other water using operation if the level of contaminant does not interfere with the water using operation. That is uses both wastewater volume without changing the mass load of the contaminant. So comparison The system proposed by EWRM, this is proposed by IEWM for the satisfying most. This is the proposal proposed by WCA with regeneration, partial regeneration. The system proposed by IEWRM predicted a freshwater saving of 35%, wastewater rejection by 19.8% by retrofitting treatment for the ablution and the rainwater source. Okay, the system suggested by the water pinch method predicts 65.1% freshwater saving and the 51.5 wastewater rejection for regeneration. Even before regeneration, it's a lot, meaning we just recycle or reuse the water someplace else. The water suggested by okay, and 85.5% of freshwater and 67% wastewater rejection after regeneration, which is a lot, from 29 to 4.22 method. With regeneration, both the IEEWRM and the water pinch method use microfiltration treatment, hence the payback period will almost be the same except for the additional piping system. However, the water pinch method gives much better freshwater saving. Say in the worst case scenario, there is no rainwater to season or heating rainwater as a source. And going through same calculation using the water cascade table with partial regeneration of ocean water, as previously, a potential freshwater saving of 63.9 and reduction of 65. So for the worst case scenario in this case is there's no rain. So we just omitting the rainwater as a source altogether. We calculate using the water cascade analysis, water cascade table. The potential freshwater saving based on this theoretically 63.9%, and the wastewater rejection is 72.5%, so which is better, still better than the IEWRM method. The WPA can target minimum freshwater and wastewater flow per design, while the EWM method need to design the system. Okay, this is the advantages of using WPA, water pinch analysis. So we do the calculation when we know already. Based on this condition, we can reduce up to how much? 65%, 85% regeneration. But for the IE Belgium, they didn't know. They need to install the system first. Then they do the testing and see how much it's reduced. So with WPA, one can especially and sustainably plan water saving for building. Able to identify inferior design option priority. Knowing the target and the maximum potential saving impact of design is indeed a crucial guideline in order to determine the best possible design that can yield the most efficient work. Where this design target this design is the way of the potential saving until recycling network is constructed. This is all exercise. Okay, we do this case study, 30 minutes. So this case study is based on a paper in, you can find in Elite, I think the last paper 5 or paper 4. It's a Tan et al. Paper 2007. Huh? So in this paper mill process, used paper is fed to the pulpers. This is one of your exercise. Need to submit to MPE. Consider an activity where it is blended with dilution water and chemicals to form pulp slurry called stock. The paper sheet formation begins when the stock from pulpers is sent to the fermentation of the paper machine. Figure 3 shows that total 986 ton of fresh butter is fed. Right? Satu. Satu sembilan lapan. Sembilan lapan. Oh, okay. Figure 3 shows 986.52 ton of water is fed to the paper machine via stream 1 and stream 2. This one, paper machine section. Remove debris while wastewater is removed from the stock during paper sheet formation. Part of this water source. Part of the water source, stream 5 and 6, are then sent to the white water tank along with recycled water stream 9, stream 9, stream 9. Okay. From the other process in the inking pulper. Yeah. So the IPT refers to the inking pulper. The IP source stream worth 54 tons per hour is mixed with 17 no, coming from stream 11. We dilute the stock in pump, we get a bit later. In the approach flow system area. Oh, yeah. Okay. Freshwater stream 10 is also used to dilute the inking chemical in the chemical solution section CP. Before the chemicals are sent to the DIP unit to cease inking removal. In addition, other process DIP to receive 201 unit. Freshwater stream 4. As for the wastewater collected from the preparation and DIP streams covered in the in sent to the effluent and set to chamber and stream the in part of the block. Most of the stream this one. Calculate the minimum utility target for the paper mill using the cascade analysis technique. All right. So table 1 shows the water demand and source for the case study. So water demand is water inlet. Stream 1, 2, 3, 4, 7, 8. 1, 2, 3, 4, 7. 8, 7 city. Oh, confusing. 5, 3, 1, yeah, 2, 0, 1. Oh, why? Station 200. Yep. Yeah. Oh, station 200. ชื่อเราเลย So we do it based on the table, regardless of where it come from. For our case, we just need the concentration in order to start the water cascade. Sorry, double water balloon or water cascade analysis lah. Or we can say water cascade table. Table is easy. Okay. For the water source, 2, 3, 4. The source is water after the process. 11155 and 4, 100 ppm, 1305.78, 250 ppm. Oh, this two, let's see, 2.14. Yes, correct. 200 ppm ya. Tahu. Then we have 170 ppm here, coming from what water tank. 20184 or coming from others. One coming from the IP. 469. 415 plus 54. So plus 69, yes. Because stream 12 is a 100. Stream 13. But from the IP is 13, 12, stream 12 plus
Doctor, on the water source for 2 and 3, how they get 1305 and 201?
201.34. See? What the source? Oh, what the source? 1305 is. It's this number, this number. Then you get 1305.78. For 201, coming from others, 201.84, this one. 469, coming from the IP, it's here. summation of these two. Then you get 469. Saya tambah tu lah. Just
Okay.
now that we understand the diagram, so pasti saya dah tahu 220 lah. Okay, no worry, doesn't need to know. Then we do the cascade lah. So to do the cascading, we should start with FFW0. Oh, start with interval. Salah apa tu? It's the same thing, but super similar. Oh, memangnya silap dah. Silap dari awal dah. So it should start with the interval. This one. This one. Yeah. Right. Right. Um, so it should start with interval. So interval is n, level is k. I think most of the paper will stick with that nomenclature. So interval, start with interval 1, 2, 3, 4, 5, 6, 7. So the next column is the concentration in ascending order. Start with 0, go to this level. With 0, 20, 220, then 50, 100, 170, and 40 is from the source. 200 from the 1, 50, source is from the source. At C, concentration 0, purity is 1. So this is the fresh water. So in this case, the fresh water, they assume it's very clean. So the source is 0 ppm. Walaupun dia sebut, dah kan disebut. It's equation actually. Okay, since it doesn't specify how clean is the fresh water, then yes, we can start with 0. So here, one is calculated by equation 1 from previous paper. Sultan Ismail in most paper. 1 million minus C over 1 million. You do for 2080 till 250. When we calculate the delta P is the interval between 1 minus 0.99998, get this value. Then the summation for the demand. So for negative 190.08, this one is aligned with the 20 ppm. For the 20 ppm, we have two value. 155.4 plus G8 plus 34.68. Then we get 190.08. So since this is the demanded water that will be used, negative sign. For 80 is straightforward. Just take from the table 1. For 100, okay, 100 from demand only one, okay, 201, negative 201. And the unknown from 170 for demand, okay, 200. So for 200, there are two source. 1149 plus 68.7, 1217.7. Right? Masih cuma. Oh, saya dah perpuluhan. 1218.54. Then for the source, you do the same. For that source, it's 100 here. Started at 100, 155.4. 170 ppm is 20184. 1305.7 is 230. Okay. Then summation of demand and source. The first purity level 0. Second, 190 plus 0. There's no value here, so just bring it here. For this one is negative 2014 plus 155. Get negative 46.44. And this one is negative since it's demand on. Okay. For the FC, okay. For the FC, it started with FFW. So for the FFW, it should start at 0 first. From 0, we identify the minimum water target. Although in here, the FFW we already specified at 148.12. So this value is coming from here, the pinch at purity level apa? 230 ppm. So here the value is negative at 48.1. So you need to do this. Siapa kayak nak buat? Still got time. Ada 30 minutes. So if we start from 0, so 0 plus negative 190. So 0, 0, should be 0. 0, negative 190. So negative 190 equals to plus minus. Yeah, plus. Negative 831.12 is apa? One. So during the final exam, you should bring your calculator. It's easy to calculate using phone or unit scientific calculator. Calculator biasa. Negative 1021.92 plus minus 46.44, then negative 60. 36. Negative 7 point tolak 7.68. Negative. Jump in. 0, 6, 4. Do this, do the rest lah. Yeah. Yeah. Next is the pure water surplus. For the pure water surplus, is what? You need to multiply this value FC, the delta P, multiply it. Garap lah. 1, negative 1, 9 ke 4. Pasti. Oh, negative 19. 1908.95. 0.00006. Then you get the pure water surplus slash the physics. After you calculate that one, multiply it, then you do the cascading for the cumulative water surplus to determine the pinch here. Based on this FFW, the pinch is negative 848.12. So how many tables do you need to do? To answer the question, we need two tables. The first table is to identify the minimum water cascade, minimum water target. The second table is to recalculate again the freshwater feed. The freshwater using the minimum water target to identify the wastewater generated. Any question?
How to differentiate water source and water demand?
Kena. Ya, water source and water demand, yes.
Macam ni nak bezakan
Question.
dalam chart yang pertama ya. Masih si faham chart pertama ya. Jadual pertama table 1.
Oh,
Macam ni nak bagi ni demand ni source.
demand is inlet to the process. So we consider this is one process. So the inlet is the demand. See, this one is not demand. This one is source lah untuk dia keluar. Okay. So in this case, so kita depend on the table 1. So from table 1, the water demand for the process pressing shower or pressing section sama forming section, others, VIP, CP, and AF. So since the name is water demand, so water entering the processor. So for AF, let's say, there are two sources from stream 11 and the stream 12. Maybe AF. You see the value 68.7 there. 68.7 is dia tambah 54 plus 40%. So how about water source? So the process description is the same. That water source is coming from the system. 5 and 6, 7, yes. So for pressing shower, only 5. So 1, 5, 5, and 4, same, 5 and 4. For the forming section, there are two source, 41.28 and 124, 1264.5. If you add this up, you will get 1305.78. Others is 101.84, tip number 9. Okay, VIP. It's only one, although there are two. You see 12 and 13. But the source is here. Yeah. So you need to add it up or sum it up to get 469. For the question later on, the table is given. The flow chart is for you to understand the process. But ultimately, for the calculation wise, yeah, we will refer to the water demand source. Specify for the process. So you try this. You start with 0. Get the 848 here. This one, if you start with 0 here, the value should be 848. When Yeah. If you refer to something regeneration, yeah. Sekejap, ah. So for the paper mill case study, you see the PPM, right? So the PPM is based on TSS, the suspended solid. For the case study, Sultan Ismail Mas is using BOD as the based on BOD value, water quality. So the regeneration. So for the regeneration, if possible, do it at, before above the pinch. Here is this one is the best. Yeah. 1305. The concentration is very high. 230. Yeah. Since the concentration is high, then you need to find yang depan lagi lah. Because regeneration, there are many type of regeneration. Ada masuk sini. Power kah? There are many type of regeneration. Oh, gas. Okay, gas is next week lah. Many type of regeneration. So some of regeneration, yes, can get like 230 ppm goes to less than 10. But some a cheaper version, you can say, less expensive. It cannot go up to that uh, purity. So depend, man. But you can choose any, if possible, choose of the pin so that you can reduce the freshwater need. Water generate. Any question to do this? Then I recommend you use Excel. It's easier. But during the exam, you cannot use Excel. So you still need to calculate manually. All right. So you can also email me, step through the group, and as well the communication. This is mm, tomorrow is about gas. Gas is different, like very, very different. Because water is easier than gas. Water, because we can say fresh water is 0 ppm, but for gas we cannot say that because at purity level 1 for gas is very, very expensive. So most of the time the FFW is not 0, but at certain ppm. Take your attendance. Thank you. Boleh buat? Kita bila ya? Sekitar Selasa. Exercise. So thank you.